Hi, welcome back. So we are still here in our topic, material and energy balances. So now we will gonna determine the basic principles regarding the two. Okay, so if the unit operation, so say we have this unit operation here. For easy recognition and for illustration, let's be represented it by using diagram or using a box like this. So for the sake of the illustration, so each unit operation, let's represented it using a box. Okay, then by following the conservation of mass and energy, so what goes into this system or to this box must balance to the mass or energy that is going out. So let's represent it using an arrow going in and going out on the system. In, out. Okay. So for material balance or mass balance, following the conservation of mass, which leads to the mass or material balance, remember that we says that mass in is equal to mass out. Okay, so for this material or mass balance, say our usual input, we call this as say raw materials. Okay, so during the input stage or the mass in, we can have a combination of different raw materials. Okay, can be 1, 2, 3, or many more combination of raw materials. Okay, so we have these raw materials going into the unit operation, and our output can be either it can be what we call the product or our desired output. Then it can also be a waste product, the product that we do not desire. And what else? Okay, so in case we have these two, by using our law of conservation of mass, having this input and output material going in and out of the process, we can now say that raw materials, the summation of our raw materials, say let's denote it as MR or material raw material, is equal to the summation of our products, our mass of the product, plus the total waste product. Let's call it waste. Okay. So as you can see here, having this concept, we can now broaden our equation by having these raw materials as our input and the what we call product and the waste product as our output. So we can further what do you call this, expand this equation if you have a different raw materials. Like for example, this summation here denotes to the total raw materials of, say, you have a raw material 1 plus raw material 2 plus raw material 3. So you have a combination of 3 different raw materials that is going in or being processed into this box here, is equal to the say you have also a 3 products, say your product 1, product 2, and product 3. Okay, plus of course the summation or the total waste that is being collected. Okay, say you also have 3 types of waste material. So you have waste 1 plus mass of your waste 2 plus mass of waste 3. Okay. So whichever might be the situation, as long as you follow the basic principles of the conservation of mass, which is what goes in must be equal to the mass going out, then you can denote your materials that is going in. Either you have 3 or more or 1, and as well as to your output, such as your product and your waste product. Then using the principle of the conservation of mass, then you might always lead up to the balance equation of the two. Okay, so here's another scenario. Say this is once again our operation. Then we have the quantity of materials that is being going into the operation and going out. Then there are times, or realistically there are some materials that is being stored here in the operation. Okay, maybe some quantities are stick into the equipment and so on. So there is a material that is being stored during the operation. Okay, so in order for us to follow the conservation of mass, we must also include this stored material in our equation. So what is now our equation? So using this, we can now add the stored materials into the other side of our equation. So we have mass in, so we have our mass or material entering materials. So say we have mass in to denote the total mass that is going into the process, and of course our material at our exit, or our exit materials. So say this is our mass out, plus we can now add the material that is being stored in the plant. So say this is our mass stored. Okay, to balance the equation and to account all the quantities of the materials that is being processed on this process. Okay, so let's expand this. So on our right hand side of our equation, we have our mass that is going out, which is it can be the product or the waste product, and plus the material that is being stored on the system. Okay, so there are cases that this um, this will not be equal. So mass in is not equal to the mass out plus mass that is being stored in the product. Okay, so in these cases, if we have the unknown materials, or we cannot identify where is this materials, why is it the mass in is not equal to the mass out plus the mass that is being stored. So in order for us to account this, we need to add those materials and say that the unknown material is the what we call the losses. So we have the mass loss to account all the materials going in and going out on the system. So finally, we have this material balance now. So we have the raw materials, the mass that is going in equal to the mass out, which is our product and our waste product or byproduct, then the material that is being stored or the stored product, and then the losses. Okay, so once again, whatever the situation is, we need to follow the conservation of mass, which says that the material balance must be must follow the concept, which is the mass that is going into the process must come out. Okay, so all in all, we have these formulas here from basic principle of this mass going in and out. We have the raw material as our mass going in and our material mass going out in terms of the product and waste product. And we've also defined if there are different raw materials and as well as the different products and byproducts. And then to account also the material that is being stored in the plant, then we've added it on the right side of the equation to balance the mass that is going into the system. And if you if we measure the mass in, the mass out, the total quantity of mass out, either it is a product or byproduct or waste product, then we've also identified the mass that is being stored in the system, and it turns out that the input is not equal to these two, then we can add the what we call losses to account those materials and those masses to come up with this balance equation. Okay, so all in all we need to do is to follow the basic concept of the conservation of mass, which is mass in must be equal to the mass out. Okay, so that's all for the material balance, and on the next video we will gonna establish this basic principles for the energy balance.